Okay, we're going to look at a new component that you might not have come across before called the transistor. Boiling it all down to very simple things, a transistor is basically a switch, and it switches on when it gets a certain amount of voltage across it. Okay, and that's the basics of a transistor. There are two types of transistors, and the different type will tell you at what point they turn on. Okay, so there's two types, the NPN and the MOSFET. The NPN turns on at a lower voltage than the MOSFET does usually. You'll always be told what voltage it turns on at in a question. You don't need to memorize that. But you just need to know that that's what they're called, and you need to be able to label them as well. Okay, so transistors are used lots at the moment. They're usually combined in more complicated circuits, but we're going to just look at the basics of them today. So first of all, the NPN transistor. So this is the circuit diagram for an NPN transistor. And as I said, you need to be able to draw and label it. So you've got base, collector, and emitter. You don't need to know how they work for National 5, but you will learn about them in higher. So again, an experiment, which I will link you to a video of this experiment, but I'm just going to talk you through it. So we can see here, we've got a transistor here. That's where our transistor is. So what happens is, we know this part here is a potentiometer. So we can move that slider up and down, and we can make it a smaller voltage if it was here, or a bigger voltage if it was here. Okay. So what we're going to do is we're going to alter the amount of voltage that goes into the transistor by altering this slider. So we'll start off with the voltage being quite low. So we'll start off with the slider being down here, and we'll eventually move it up so the voltage is quite high that goes into the transistor. And the voltage that goes into the transistor is just this bottom voltage here, so the voltage across that part there. So we're going to be changing this voltage by changing the slider, and then we're just going to keep an eye on what happens with the transistor. So you can see this transistor is then connected to an LED. So when that transistor turns on, the LED will also turn on. Because as soon as that transistor turns on, it can allow electricity to flow through the LED and for the LED to light. We can also monitor the voltage out across the LED. So obviously when the transistor is off, there won't be any voltage across the LED. As soon as the transistor turns on, we will get some voltage, we'll get voltage across the LED. So really what we're looking for is the point at which the voltage, the transistor turns on. So the transistor has enough voltage to turn on, to switch on, and then to allow the rest of the circuit to work. So that's what we're going to be doing. And I have got some sample results here. You'll watch the video of the experiment yourself, but you can see all the way, so from 0.1 blah, 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 all the way to about 0.55 volts going into the transistor is off. It doesn't turn on. Then we get a little bit of sort of like a little tiny bit of voltage here, but you can see the LED is still off. But as soon as we get to 0.7 volts, it jumps to 3 volts and the LED turns on. And then it very quickly gets up to that total voltage of 6 volts, and it stays there and the LED stays on. So anything above 0.7 volts for this transistor, and each transistor is slightly different, but for this one, anything above that 0.7 volts means the transistor is on, and whatever is connected to it, so in this case an LED, is also on. Now if you were to plot a graph of this, your graph would look a bit like this. So you can see the blue line, it's 0, 0, 0, 0, 0, 0, 0, 0, 0, and then it creeps up a little bit. As soon as it gets to 0.7, it jumps up, and it then becomes 6 volts. Its total voltage is on. Okay, so about 0.7 volts is when it turns on. So it says here, in conclusion, when the voltage at the base of the transistor, so that means the voltage, that bottom bit of the voltage, is less than 0.7 volts, the transistor is switched off. So it's not on, it can't let any voltage through it. When the voltage at the base of the transistor is greater than about 0.7 volts, the transistor is switched on, and it'll switch on anything that it's connected to. As I said, 0.7 volts is for this NPN transistor, but other transistors might turn on at slightly different voltages as well. So you'll always be told the voltage that a transistor turns on at if you need to know it. Just at the bottom there, it says, describe why it's a good experimental practice to take readings at 0.05 volt intervals between 0.4 and 0.9 volts, but at large intervals at very small and large input voltages. Well, it's mainly because we want to see that point at which it turns on, and we want to find it as accurate as we can. So if we take it in smaller increments around about 0.7, we can see it a little bit more accurately about where it turns on. Lower and higher is just 0 or 6, so we don't really need to do it at small increments there. Okay, so that was an NPN transistor. The other type is a MOSFET transistor, metal oxide semiconductor field effect transistor. You don't need to know what it stands for, you just need to know it's called a MOSFET transistor. And you also need to be able to draw and label the symbol for it, which is there. We've got gate, drain, and source. Again, you don't need to know like the inner workings of it, you just need to know how it works in a circuit. So very similar experiments here, and again, I'll link the experiments to you later, is we're again using this potentiometer to alter the voltage here. Okay, so we can go from the very small voltage and we can go all the way to a very high voltage there. So that voltage is the important thing there. We can see we've got a MOSFET transistor here. So when this voltage gets high enough, this transistor will turn on, and then whatever is attached to it, so in this case again, an LED, will turn on when the MOSFET transistor turns on. We can monitor the voltage across the LED as well, just to show when it's turning on. Okay, so the results for this one, very similar, but different, as I said, different transistors turn on at different voltages. So we started off, it's not turned on, 0, 0, 0, 0, 0, until we get to about 1.6, where it starts creeping up. And then at 1.8, it's jumped up and our LED has turned on. And then it goes up to 6 and it continues along to 6 and it continues on. It's still on because it's still above that point where the transistor turned on. Okay. So again, if you would plot the graph of this, it would look similar to the other graph, but our numbers would be slightly different. So in this case, it's 0, 0, 0, it's off, 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 and then the transistor turns on, and we have this big jump up to the total voltage. And the jump happens when it turns on, which is around about 1.8 volts. So, in conclusion, when the voltage at the gate of the transistor, so that's that bottom voltage, is less than about 1.8 volts, then the transistor is switched off. When the voltage at the gate of the transistor is greater than 1.8 volts, the transistor is switched on. So this is a new type of piece of equipment that you haven't really come across before, unless you do practical electronics, of course, which you probably will have. So next lesson, what we're going to do is we're going to put it into context and put it into some circuits and see how it works. But all you need to know about transistors is at a certain voltage, they turn on and then they allow current to flow through whatever is connected to them. And under that voltage, they're off and they don't allow current.